Hello and welcome to VEX Robotics for Competition, a tutorial for new teams, presented by McCallum Robotics of Austin, Texas, Team 8756. This portion of the tutorial will cover driver control programming from motor setup to tank and arcade drive. Motor setup. I've opened RobotC to begin my driver control programming. You should get this start page to start. We're going to work in the competition template because we are programming for competition. We'll just start right in there. You'll want to go to File, New, and choose Competition Template. I've already set up a lot of files in the various steps of this process, so I'm going to open up my own file, which is exactly the same as the competition template. So the competition template has 4 parts to it. It has a header section up here at the top, which includes some definitions, sort of setting up parameters of the program. Then it has a pre-autonomous section. This section of code is run before the autonomous, surprisingly. And so once you put your robot on the field and it's powered on and it's synced with your controller, then this code will run. And you can do things in this code like set your servo positions or clear your encoders so that they have a good base value. The third section is the autonomous section. In here you place your code that's going to send instructions to the robot during the autonomous period of the competition. And then down here at the bottom, the 4th section is the user control, and you'll put your code to control the robot via the controller inside this while loop. So the while true is always true, and so it'll constantly be checking the code in here during the game, during the competition portion of the game where you're in driver control, and it will respond to your controller. So the first thing we need to do is we need to describe our motors to the program so that we have our motors named and can use them in our code. So I want to go to the menu for Robot and look at Motor and Sensor Setup. And in here there's several tabs, one of which is Motors, and it's a list just like the list we made in our wiring diagram. So this should be pretty easy. I'm going to put in my first motor's name, which is Flag Twirler. And then I want to give it a type. There's the old 269 motors, and then we're using a 393 motor. We'll talk about the option of reversing later. Let's see what this does when I say OK. What it does is it adds a definition up here for the motor. So it's saying that there's a motor in port 1, and it has a name of Flag Twirler, and it is a VEX 393. So I can now refer to this motor in my code as either port 1 or Flag Twirler. This is like a nickname. Now if I change the code here to 2 and save it, I can go back to my motor and sensor setup and see that it actually moved it for me. So you can write the code yourself. This interface kind of just streamlines the process and lets you look at it all in a way that you can use pull downs. So I'm going to change it back to 1 and go back in. Now I can input all the rest of the motors. I've actually already done that in another program, so let me just jump to it. All of the motors are now input. If I go to my motors and sensor setup, I'll see that I've just typed out all the options. So I have drive left front, right front, etc. And they're all defined as the 393 motors, and some of them are checked for reverse. So when you're sending an instruction to the motor, positive values turn the motor clockwise, and it's clockwise when you're looking at the green back of the motor. So if you're looking at the back of the motor where it says VEX, that's about where the axle is. You can imagine the axle going out from there, and a positive instruction to the motor turns it clockwise, and a negative instruction turns it counterclockwise. Now when you're working on the robot, you may have several motors that are working together to perform one task. So for example, our drive motors are all working together to perform one task. And if I send an instruction that's positive to say drive forward, well, some of the motors, depending on how they're oriented on the robot, will actually drive forward by moving clockwise from a positive instruction. But some of the motors, depending on how they're oriented, if you give it a positive instruction and it turns clockwise, it will actually drive the robot backwards. And so for those, you would need to check this reverse option. And what that does is it says every signal I send to it, it will invert it. So if I give it a positive instruction, it will make it a negative instruction. And that way, when you're writing your code, you just send a positive instruction to all the motors to drive forward, which is logical, and this reverse will flip that instruction so that it actually gives a negative value to the motors that need it in order to move in the direction you want it to. So I've studied my robot, I've imagined this clockwise rotation and how it's oriented on the robot, and I've checked the motors that need to be reversed. So now we're going to look down in our driver control area, and we know we need to give it instructions here. Our instructions are going to be sending in information from the controller to the motors. So I know I need to do that. I've already opened some areas over in here. Looking in the function library, we can see there's a motor category and a VEX remote control category. And there's some functions here, and if I mouse over them, I get some information. But since I'm new, I really don't know exactly what to do with that. This function library is really helping you, if you have an idea of what you want to do, find the function that could do it. So we need more help than that. So the help menu is where we're going. We're going to open help. This has all kinds of stuff about the interface. Lots of useful information. The one we're going to use the most is the RobotC functions and code examples. And it's in alphabetical order, so it's not necessarily starting, here's how you start and get going. But it does have a lot of great information, and the area that we're going to study now, and probably most often, is remote control functions for VexNet. So if I open that, it shows me my controller, which is what I'm trying to figure out. And it's highlighting the fact that on the controller, the button groups are numbered, and the joysticks are numbered. So this is button group 7, and there's an up, down, right, and left. And here's joystick, the left joystick, and there's a 3 and a 4. This is channel 3 and channel 4. If I scroll down a little bit more, I'll see that I'm going to have a reference to all these different possibilities. So these are the signals that the controller can send to the cortex, which then passes that to the motors as a value. There's 2 controllers listed because you, in competition, can run 2 different controllers. One might be for driving, one might be for lifting. I'm going to first, before we go into the code portion, show you what signals you're getting out of this controller. There's actually one that's not listed in here, not shown on the controller itself. It's the accelerometer, and we'll see that it does weird stuff. So let's look at that. Signals. Here we have a simple program for looking at controller signals. I've defined variables for every one of the outputs, and then have a task main and while true, which means that these will be constantly updated while the program is running. And there's a variable. The variable has been set to the signal coming from the controller. So this will let me look at the signals. I will download and compile that so I can look at it in real time. And when I press start, we'll see we're getting information from our controller. So these are the accelerometers. I'm not sure how you could possibly use these. My controller is sitting idle on my desk and the numbers are changing. So this is only valuable because of what it's telling me is that the controller is constantly sending information. Even though these numbers are not changing, the controller is constantly sending zeros out of every button. But if I press a button, it'll switch to 1. So I pressed 5 up and now it says 1. So the controller is constantly sending zeros or 1s to represent true and false of button presses. If it's not pressed, it's 0, and if it is pressed, it's 1. messing with the right joystick. I'm moving it forward and backwards, so I'm adjusting channel 2. And you'll see that it goes from negative 127 to positive 127 when I get it centered. And then if I do it in a circle, you'll see that it combines the different values from channel 1 and 2. Any range from negative 127 to positive 127. Same is true for channels 3 and 4. So that's what we're getting out of our joystick. We're getting zeros and ones for our buttons. We're getting ranges from 0 to 127 positive and 0 to negative 127. So full range negative to 127 to positive 127 out of our channels. And we're getting pretty much nonsense information out of our accelerometer. Using joysticks for tank drive. Now we have a sense of what these outputs are doing, the signal that it's actually giving to the cortex. This is the function we were using in that signal program. So let's click down to it and see what it says. It's an array that holds values. So this is basically saying that this is the signal coming from the robot, all the signals, and then you're telling it which one of the signals you want to actually use. And this is the drive function that we're going to need to make our tank drive work. So it's saying motor, and then names the motor, is equal to the signal, and then names the signal. So this signal on channel 2 is from negative 127 to positive 127, which means that this motor will always stay equal to that. So when I push the paddle forward, it gives it a signal of 127 and it drives forward. So now we know what we're looking at. Let's go down into our user control section. Inside the while true is where we're going to put our code. I'm going to replace that with a plain language description of what I want to do. So what I want to do is I want to make a tank drive with the left side on channel 3, because that's the left joystick, and the right side on channel 2. Doing this first before you write code does two things. Once you're done writing the code, it's describing what's below it. And while you're writing the code, you can refer up here to make sure that you're following along with your initial plan. So I know I need to do something with motors and Vex remote control, and now I have a little bit more of a clue of how those work. I can drag this down here, and it sets up my motor function. And in here I need to describe, name the motor I want to control. If I click inside there, it's pretty good about giving you the list of options. There's all the port numbers in addition to the nicknames that we gave. So I'm going to do the left drive, that's drive left front. And I need to set that equal to a signal. And if I click in here, yeah, sometimes it doesn't work. But if I start typing channel, it will give me all the channel options. And you'll see I did a lowercase c, but if I click here, it corrects it for me. C is case sensitive, and it needs all the right bits of text in place in order to work correctly. And the one that you miss most often is forgetting to put a semicolon at the end of each statement. So this is going to tell my left front motor to go at whatever speed is coming from the signal from channel 3. I've got 4 drive motors, so what I want to do is copy this 4 times and then name the correct channel and motor so that all 4 motors are working when I'm driving. So I'm going to copy, paste it 4 times, and now I want to make the left back motor to channel 3 and the right front motor to channel 2. So the right side's on channel 2, which is the right joystick's vertical. Change that to 2, and then the right back motor is also set to 2. If I press F7, it will check my code. It's going to compile it, and it'll check it for errors. So for example, if I left off a semicolon here and I run it, it's going to give me an error because it didn't get to a semicolon. It even tells you what the error is. The red X's mean that it's an error that will actually make the program fail. You can get yellow X's, which are errors that it knows how to correct and correct it for you, and you can get gray errors that are errors that really won't damage the program. So I need to put my semicolon back in. I'll test it again. I didn't get any errors. I'm going to now download it to my robot, and then we'll see if it drives. So I've downloaded the program, and I should be able to have a tank drive. They've synced. I see the green flashing lights on my robot, so I'm going to press the left paddle forward, and we get it turning, and the right paddle forward, and we get it turning. Both together and they drive. We've got tank drives. Using a joystick for arcade drive. Great success, we have tank drive. That is the most common way people tend to drive. There's another method which people refer to as arcade drive, where you map the signals all to one joystick. So I'm going to comment out my code for tank drive, so this will no longer be run. Anything preceding double hash as a comment won't run. And I'm going to write out my plain language description of what I want to do for arcade drive, which is arcade drive is using channel 2, which is the vertical channel on my right joystick, for forward and reverse, and channel 1 for turning. Let me copy these over, because I know I need to have a signal for every motor. They're commented now, so I need to uncomment them. If I do Control Q, it uncomments. So I know I need to send a signal to every one of the motors to get it to drive. What's important to remember is that this is just a number. It's a number from -127 to +127, and because it's a number, it can be operated on mathematically. So I could add 50 to it so that it's always going at least 50. Or I can divide it by 2 and add 50. It's just a number. So if I want to have it run on channel 2 for forward and reverse and channel 1 for turning, that means I'm going to combine those two signals for every motor. So all of them need channel 2 for forward and reverse. So I need to put them all to channel 2. That's going to be part of their drive. And they're going to also need to get a signal from channel 1. So I'll do, let's just say plus channel 1. They're all going to look like this because they're combining the two values. So I'm going to copy these all down. But I'm not quite done because I need to think about what I'm actually sending to these different motors. If I want to, this is the drive forward and backward part of the drive. And when I press forward, I want the motors to go forward, and when I press backwards, I want the motors to go backwards. So these don't need to be changed in terms of their positive or negative value. However, this is the turning component, the channel 1. So if I want it to turn right, I have to imagine what signal I'm sending to the motor. So on the left drive, if I want to turn right, I'm doing the paddle towards the right, which is a positive number, which would be making the left drives go forward and turn towards the right. So that's correct. I'm adding the right component and it's going right. Now if I add a forward, a positive value to my right side, telling it to go right, it will actually move those motors forward, which would turn it to the left. So I have to invert the signal going to the right so that the right side, when I'm telling it to turn right, goes backwards and therefore does turn right. A lot of times you'll see arcade drive have a little bit more math to them where they'll divide everything by 2. And the reason you would want to do this is because if I add 127 and 127 together, that is more than the maximum motor value. It's twice as much. So if I divide it by 2, I know I'm never going to exceed the maximum motor value. There's a problem with this, is that if I add 127 to 0, meaning I want to drive forward full speed, I get 63 for a power, and that's only half speed. So this would automatically make you go slower. What is going on though is that you're sending a signal to the cortex, and then the cortex is relaying that signal to the motor, and the cortex will check to see that if it's too big, it will give it the maximum value. So if I give it a value of 200, it will actually send 127. So it is safe to send this signal straight through to your motor because the cortex will correct for me. So I'm going to download this guy, and we'll switch over to the camera and check Arcade Drive. So now we're testing Arcade Drive. I'm only controlling with the right paddle. I'm going to do channel 1 to the right, so the right paddle. Right and left on channel 1 turns it. Up and down on channel 2 drives it forward and back. And I can do combinations, so if I go diagonally, it kind of does an arc. Thank you for watching.